App service deployment slots allow organizations to host multiple versions of their applications within the same app service instance. By creating distinct environments, such as staging, testing, or production, administrators can ensure that code changes undergo thorough validation before reaching end users. This separation greatly reduces the risk of downtime and service disruptions while streamlining release cycles. In earlier units, we detailed the steps involved in provisioning an app service and configuring its scaling options. Building on that foundation, this section focuses specifically on the creation, configuration, and management of deployment slots to optimize continuous integration and delivery strategies in Azure. Deployment slots provide a dependable way to test new features or patches without impacting a live environment. By deploying updates to a staging slot, developers can validate functionality, run automated tests, and confirm performance baselines prior to releasing changes. This approach significantly lowers deployment risks and improves version control. Additionally, by leveraging features like warm-up requests and custom domain settings, organizations can seamlessly transition from staging slot to production with minimal downtime. Furthermore, these slots facilitate a rollback strategy, where the previous slot can be swapped back if issues arise, ensuring operational continuity and preventing unexpected application failures. To create a new deployment slot within an app service, administrators can use either the Azure portal, Azure CLI, or Azure PowerShell. In the portal, select Deployment Slots to add a new slot, specifying a unique name and whether to clone existing configurations. Cloning duplicate settings, connection strings, and environment variables, simplifying environment setup. Alternatively, scripts using the Azure CLI facilitate automation and DevOps integration. For instance, bash AZ web app deployment slot create / name app service name / resource group / slot staging / configuration source app service name. This command creates a staging slot and optionally copies configurations from the source app. Slot settings determine how your application behaves upon deployment, enabling flexibility and isolation for different environments. Administrators can set environment variables, connection strings, and other configurations specific to each slot. By marking certain settings as slot settings, values remain unique to that slot and do not shift during a swap operation. This distinction helps avoid overriding credentials or environment-specific keys that are critical for testing or production. For example, a staging slot might connect to a different database endpoint or storage account than the production slot, ensuring safe experimentation without risking the live application's data or performance metrics. Swapping is the primary mechanism for moving new code into a production environment once it has been validated in a staging slot. Initiating a slot swap effectively exchanges the application content and runtime environment between slots. Organizations can also manage a gradual transition by splitting traffic among multiple slots, allowing a percentage of user requests to access the new deployment. This approach, known as traffic routing, helps detect potential performance or compatibility issues before a full transition. During the swap, application warm-up routines can minimize downtime by preparing the newly promoted slots processes to handle live traffic quickly. Implementing zero downtime deployments involves carefully orchestrating slot swaps and warm-up tasks. By preloading assemblies, caching, and running initialization scripts on the staging slot, administrators reduce potential performance dips when the swap takes place. Additionally, using the auto swap feature in Azure App Service can automate the process, triggering an immediate swap upon successful deployment to a staging slot. This strategy eliminates extra steps in the release pipeline, particularly when paired with continuous integration. However, organizations should manage rollback procedures carefully to ensure a viable contingency plan. Properly documented steps enable a seamless return to a previous version if necessary. Deployment slots align well with modern DevOps practices, as they can be integrated with popular CI/CD tools such as Azure DevOps, GitHub Actions, and other pipelines. By configuring build and release pipelines to target specific slots, teams can orchestrate deployments automatically after code commits past testing stages. This automation typically involves YAML or JSON-based definitions that specify how artifacts are built, tested, and deployed to a named slot. Once verification is complete, the pipeline can trigger a swap to production. Such integrations reduce manual steps, maintain consistency across environments, and expedite the feedback loop for developers and stakeholders effectively. To ensure reliable deployment processes, certain guidelines are recommended. Firstly, configure all app settings and connection strings that differ across environments as slot settings to avoid accidental overwrites. Secondly, monitor performance metrics and logs before finalizing a swap, verifying that the staging slot meets all functional and operational requirements. Thirdly, plan for rollback by maintaining backups or snapshots of essential resources. Lastly, consider gating strategies like canary releases, where a fraction of traffic is directed to the new deployment for incremental validation. Following these best practices helps maintain high availability, lower disruption risks, and streamline release cycles. Deployment slots often rely on environment-specific credentials, tokens, or application secrets. Protecting these sensitive configurations is crucial for maintaining application security. Azure Key Vault integration is a common approach, enabling administrators to store secrets outside the app service environment and reference them securely. By combining Key Vault references with slot-specific settings, organizations can further isolate sensitive information from unauthorized access. Additionally, rotating credentials on a regular schedule or upon slot creation minimizes the window of exposure. Administrators should also enforce access policies within Azure Role-Based Access Control, RBAC, to limit who can view or modify critical settings. For comprehensive management, many organizations leverage infrastructure as code, IAC, solutions, including Azure Resource Manager templates or bicep files, to declare deployment slots in a repeatable way. These files capture all slot-related configurations, including settings, scale rules, and environment variables, ensuring consistency across multiple stages or geographies. Additionally, scripting with PowerShell or Azure CLI can automate slot creation, swapping, and deletion as part of continuous integration processes. Advanced pipelines may include approvals, notifications, and testing gates that trigger or halt particular actions. Through these techniques, teams gain enhanced control, scalability, and reproducibility in their app service deployments.